Before we begin talking about skeletal muscle relaxation, I want to bring in a term that I just realized I had not even mentioned yet, and that is sliding filament theory. Now remember, in the previous image, you saw the shortening and elongating back to normal length of the sarcomere because the myosin heads were pulling on the actin filaments, and the actin filaments were sliding across the myosin. So that's the important thing I wanted to bring up here, is even though that sarcomere shortens, it is not shortening the myofilaments. It is simply sliding the thin filaments past the thick filaments. Therefore, it is called the sliding filament theory. Now, as we begin relaxation, I want to start by playing this video for you, and I'm also going to upload 3 additional videos from Pearson Publishing that will be standalone videos not included within my lecture. But I do encourage you to watch those because those are some of the best ones I have ever seen for muscle contraction. So bear with me now. Let me get this relaxation muscle video playing, and I will also need to check the volume once it begins to make sure it's good to go. All right, so not a lot of words there, huh? But I really like the way that it breaks that down and shows very easily and very simplistically what is happening with the actin and the myosin. Now, let's look at that with a whole bunch of words. So when muscles are to relax, first of all, the nerve cell has to stop releasing acetylcholine into the synapse. The acetylcholine that is still in the synapse has to be broken down by the enzyme acetylcholine esterase. Once those receptors no longer have acetylcholine, the gates close, sodium no longer rushes in, therefore the end plate potential stops because there's nothing letting sodium in. No further action potential will be generated or propagated because we have to generate it there at the motor end plate. And if the acetylcholine is gone, receptors are not bound, gates are not open. Okay? Now, when that happens, if there is no action potential being generated along the sarcoplasm, or I'm sorry, the sarcolemma, the muscle cell membrane, then the calcium gates are going to close in the sarcoplasmic reticulum because the T-tubules are no longer depolarized. Now, the calcium that is still out in the sarcoplasm, the inside of the cell, gets pumped back into the SR. That takes ATP. Troponin goes back to its normal shape. Tropomyosin rolls back over actin's binding sites. Myosin is hanging out down there in the cocked position, ready to go the next time the actin binding sites are open. So that returns the muscle back to its reset original position.